Welcome back to our video module on statics. Today I'd like to take a moment and look at a problem that uses vectors. So I grew up near the ocean, and one of the things that I thought was always rather impressive were the barges that went both in the bay and also on the river, and kind of filled with dread should you ever get near one of them. And what I'd like to do is I'm going to draw a barge. I'm going to somewhat artificially set this up because this isn't really how they work, but we're going to pretend that we have two tugboats pulling on this thing, okay? Tugboat, we'll say Andrea. There we go, tugboat Andrea. And and we'll say the barge is moving in this direction. And Andrea is pulling at a 30-degree direction. So here's Andrea like that. And then the second tugboat that's pulling on this is, we'll say tugboat Barbara. Here we go. B. There we go. And here's our tugboat. Not very similar to the tugboats you might see, but and it's pulling at a 45-degree angle. And now these tugboats are pulling the barge right along this trajectory, so it's moving in this direction exactly. Now they're pulling it in such a way that they are exhibiting 10,000 pounds of thrust. All right, so basically that means the barge is experiencing 10,000 pounds of drag on the backside. And what I'd like to do is take a look at this problem and explore it and say, well, what's happening? What's happening? There are these cables that are attaching to the tugboat. What's happening? And you might see this in a textbook, and the textbook might say, these cables are only rated for 8,000 pounds. So are these cables adequate? Or in real life, you might actually have to figure this stuff out. Now that said, I'd like to kind of feel our way through this and see what's happening today. We're going to set up the equations, and then I'm going to give you the chance to go ahead and solve. Now the first thing that we're going to do anytime we get these problems is we're going to create our free body diagram. So here's our barge, and unless I say otherwise, all these forces, they're going to be acting at the center of the barge, so you don't have to worry about any rotation or anything like that. So first, you have the force due to A going in this direction, and it's at a 30-degree angle, all right? 30-degree angle at A, and then down here, as you're setting up the problem, you're going to have B as well, and that's going to be at 45. And it's tempting to let this go. Let's say, okay, we got our forces, but we don't. The third force that we have is our force of drag. So that's going to be 10,000 pounds. Now there's a couple ways to solve this. The first way we're going to do is we're going to start off and think, what's really happening here? We're going to try and kind of intuit our way through. Well, if we look at tugboat A and tugboat B, we see that tugboat A is pulling up. It's pulling in this direction, in the diagonal direction, and there's components of that. There's like some of it's pulling in this direction, most of it's pulling horizontally, and then a fair bit's pulling vertically as well. And what we see is the same thing is going on with tugboat B. So it's pulling in this direction. Well, that direction has some going horizontal and some going vertical, okay? What that means is that if you look at what's going on vertically, tugboat A is pulling up and tugboat B is pulling down. Now if one's pulling up and the other pulling down, it's going right in that direction. We know that tugboat A and tugboat B, they're pulling against each other just right, so they're equal and opposite. One of the ways that we can do that is say, okay, well, what's happening? Let's sum the forces in the y direction, okay? Sum of the forces in the y direction, and we're going to say that's mass times acceleration in the y direction. Now I've already told you it's not moving in the y direction at all. So this is 0. So let's see what's happening. We know that in the vertical direction, just to tugboat A, not all of tugboat A's force is going in the y direction, only the vertical component. The vertical component, from your trigonometry, here let's go with our kind of teal color, is going to be the sine of 30. So we're going to take a look at just the vertical component of A. the sine of 30 times force A. So we take the total amount as that hypotenuse, and the vertical component is sine of 30. That's going in the vertical direction. And then we're going to subtract from that, or then in the negative direction. One way is just to, let's subtract, let's move this a little bit so we have some, give ourselves some more space, is cosine of, whoops, sorry, that's not cosine, I'm getting ahead of myself. That's going to be sine as well, sine of 45. So you see where we got that? We know that it's only the vertical part of force B that is going to contribute in the y direction. So here, let's make sure our colors are good. So in the y direction, the sine of 30 times force A minus the sine of 45 is force B. Great. So we have one equation. And that all, obviously that's going to be equal to 0. Now let's look at what's going on in the horizontal direction now. We're going to sum our forces in the horizontal direction. This is going to be a little bit tricky. The sum of the forces in the x direction is once again mass times acceleration in the x direction. Now, we know that it's just going at a constant velocity. So we know the acceleration is still 0. So this equals 0, this whole equation. Well, let's see what is going on in the horizontal direction from our free body diagram. Well, we have some contributing from A. And check that out. It's not all of A. It's only the horizontal component. That's all we care about. So that's going to be cosine of 30. So we only care about the horizontal component, so it's the cosine of 30 times force of A. That's the horizontal component of A. Now in this case, we're going to add the contribution from force B. Force of B is going to be the cosine of 45. So cosine of 45 times force B. And then finally, we're going to put in our final force is minus 10,000. Okay. Now something really important here. I want to make sure that none of you thought that when we summed our forces, it's going to somehow equal 10,000, because it doesn't. The 10,000 is a drag force, and that gets included here. All right? Well, what we've done thus far is we've taken a look and gotten a feel that what's happening with these vectors is A is pulling up, and it's getting, in the vertical direction, it's pulling up, and B is pulling down, and those two are going to be equal and opposite. So they're going to sum to 0. And then we also have something going on in the x direction. In the x direction, we have A pulling in this direction, we have B pulling in this direction, and then we have a negative 10,000. Now I'm going to go ahead and show the solution for this using substitution. So go ahead and put it on pause, see how far you get, and see what type of numbers we can compare. Welcome back. I trust you've come up with the same answers I have here, 7,320 and 5,177 for force B. So according to our preliminary, or our initial problem, they're both within 8,000. Now, what I've done here is I've set up a substitution. I've kind of done it in parts where I started off with a y and kind of got force A by itself, and then I substituted that in to the x equation. You can see going through there, and then finally I found the answer, substituted that back over here, and found the answer for force A. I'd like to point out that this is a fair bit of algebra, and I'd also like to point out that here I made a notation of C30 for cosine of 30 degrees. We just do it a lot. The other thing that you should know is that the cosine of 30 is 0.866, and the cosine of 45 is 0.707. These are numbers you should just know. Sine of 45 is also 0.707, and sine of 30 is 0.5. You'll just need to know those. You'll be doing them a lot. So by using the substitution method, we're able to do quite a bit here. I'd like to show you one more method that gets us the same results, and that's as I set this up using row reduction. Here you'll see the work I've done is a lot simpler and a lot more straight to the point. So this one is the top equation is for what's going on in the y direction, and the bottom is what's going on in the x direction. Go ahead and look through this. This method of solving simultaneous equations is going to be really useful. That's it. I hope this is really helpful for getting a feel of how these vector forces work. In our next module, we're going to take a look at it even more in depth. Thank you, and I look forward to